So students are going to be practicing thinking about multiple copies of fractions. So for a tape diagram, all they're simply going to do is draw 4 pieces of tape representing each part of this problem and then putting the value into each. That's a pretty simple process. The next part is to put a multiplication sentence. So you see the repeated number, 2/3, and the students are going to count how many times they see it. So in this case, they see it 4 times. For part 3, they're going to combine what they did in part 1, leaving out the tape diagram, and then showing. So you see the repeated addition sentence here. They saw the fraction 7/5 and they saw it 4 times, so they said 4 times 7/5. They then moved the number of copies and the part from the numerator into the numerator and made a multiplication sentence of 4 times 7 because we're thinking of 7 parts 4 times. And then the denominator fifth stays the same because our unit is going to be the same size. The final step is to take this improper fraction and change it into a mixed number. I'm going to go through the process of that first step I'm going to come down to C. So the first thing I would do is I see that I have the fraction 5/12. From 5/12, I want to count how many times I see it. 1, 2, 3, 4, 5, 6. So I see 6 times 5/12. The next thing I want to do is I think that I have 12s. I have 6 copies with 5 in each copy. So that tells me I'm going to have 6 times 5, which is 30 parts, over 12. The next step, which they didn't really show you in the example, is that you want to make the number bond how many whole you can take out. So skip counting by how many make a whole. In this case, I'm thinking that 12 12s are equal to 1 whole. So I'd say 12, 1 whole, 24, 2 whole. So it's going to be 2 whole, which is 24 12s. And then what remains, I say 30 subtract 24, 6 12s. So my answer would be 2 and 6 12s. That's how students are going to solve this. This is the part that they didn't really explain how to do, but students should know how to do that. The next one, where it says solve using any method, students can choose repeated addition, like they saw up in the earlier problems, or they can choose to do that multiplication model I just explained. Same goes for C, D, E, and F. For problem 5, this is where students are applying the math to a real world situation. So here it says Colton is playing with interlocking blocks that are each 3/4 inches tall. He makes a 17 block tall tower. How tall is his tower in inches? So if we think about the blocks being 3/4 of an inch each, and he makes a tower that has 17 blocks in it, we want to think of that measurement 17 times. Students are going to go through and create that number model for each of the next 3.